The ability of ecosystems to resist and recover from stresses and disturbances is a central part of understanding the temporal dynamics of ecosystems. Here, we'll spend more time learning about ecosystem resilience and how ecosystems change. To begin, it's important to understand that the state of an ecosystem is not necessarily the only state that an ecosystem can be in, that there are also what we call alternative stable states. A given environment can often support more than one potential state of an ecosystem. And in the past, we talked a little bit about this with regards to species introductions, for example, and the differences between eucalyptus forests and grasslands that were nearby. And the presence of a species can put that ecosystem in a different state with a whole different set of conditions and processes that are associated with it. Often in ecosystems, what we see today is a function of what we call the ghost of past disturbance. So when we take a look at an ecosystem over the modern period, it might look like that. And the reason was that for a given function might be an event that happened long ago that took it and changed the state. So often what we have to do in interpreting current states of ecosystems is think about what had happened in the past. And these are often called legacies. The idea that the current state of an ecosystem is a legacy of what had happened in the past. And there might be trends from the past in either direction or abrupt events that had happened to give that ecosystem its current state. Now, another term that the chapter uses is complex adaptive systems. And the term complex adaptive systems is pretty complex in and of itself. But what it tries to represent is the idea that the system changes its properties, quote unquote, adapts in complex ways in response to changes imposed on it. This is simply another way of stating that there are multivariate responses of ecosystems, and we can't just think of it in one dimension. So the time course of an ecosystem for one property can be represented relatively simply, but there's a lot of other things that are happening in the ecosystem over time. And there's a complexity in the way that these systems respond, and the fact that there are multiple different factors that are responding at a given time, and they're all interacting. One of the examples that the authors use has to do with changes in the ecosystems of New England, so of northeastern United States. And they say that changes in landscape composition and population of northeastern U.S. forests since European colonization can be represented something like this. What we have is that before European settlement, somewhere on the order of 90% of the area was actually under forest. And then over time, as those forests were cleared, it was almost half of the land had been cleared from forest into agriculture. And so we can see on the x-axis we have time. It starts here at 1600, goes to 2000, and this is the general time course of New England forest cover, reaching its low point somewhere around 1850, 1875. Now that land had been cleared for wood and then turned into agriculture. And so you have almost 40% of the land under agriculture at that time. The population of the region was increasing exponentially, but that doesn't mean that the forest cover continued to decline over that time. It actually started to rebound. What had happened is that most of the food had been produced locally for this population, but then shifted to other parts of the country, such as the Midwest. And in response, there was less pressure on the land for agriculture, and the forest recovered over that time. Now, modern changes have also been with development, and the amount of land that's under development has increased, and that hasn't necessarily allowed forests to recover to their previous amounts. Now, the idea that when we take a look at a forest today, when we go and look at a forest today in that region, we have to understand that many of these forests had been cut down and weren't present over 100 years ago, and they would have been under agriculture. So we had lived in Hanover, New Hampshire for a couple of years, and when you go through those forests there, they look to be relatively intact and don't really show much signs of previous disturbance. Looks like a normal forest. But as you go and take hikes, for example in the winter, that all throughout these forests were rock walls. And these were dividing lines between different pastures. So all of this area and the forest that I'd shown a picture of before was actually clear cut on the order of 100 years ago. And these are relatively young forests. When you take a look at historical photographs from that period, many of the mountains are bare. And those same mountains that we were hiking up that supported relatively thick forests had been cleared for logging and were under agriculture in one form or another. The idea that a given place could be under forest or under crops and be maintained over time is an idea of there's alternative stable states. So it's relatively stable for that place to be forest, and once it's clear cut with a couple of changes in the factors that determine the vegetation, it can be maintained as a pasture or under crops. And both of these are stable. You can bounce back and forth, and it doesn't take much to switch from forest to agriculture or vice versa. So we'll often talk about the state of an ecosystem being stable, meaning that it's not going to have change on its own, and there's alternative states for those.